Geometry Chapter 7, Lesson 5, and I want to do an example video where I do a number of examples where we simplify these radical expressions. And remember, there's two things that we want to remember when we're simplifying. We want to take the radicand number, the number that's underneath the radical sign, and prime factor it. And then we want to rewrite the expression as the product of those prime factors, and then we're going to be looking for two of those prime factors that are the same, because two radicands that are the same will simplify to the whole number that's equal to that radicand. So if you watch another video, you'll kind of know what that vocabulary means. So let me do a few examples then moving forward. And I'm going to scroll down here where we have the answers so we kind of see where we're going to end up. And that's always helpful, and we still want to be able to go through the process and do it, however. So for example 1 here, we have the radicand of 576, and we want to list the prime factors. So I'm going to do this division. I'm going to do a little bit different than in the last video, but it's the same concept. We're going to divide 2 into here, and that's going to give us 288. And then that number is divisible by 2, so we're going to use that. And then that number is divisible by 2. And then that number is divisible by 2, and that's divisible by 2, and that's divisible by 2, and that's divisible by 3, and then that's divisible by 3. And so we have this long list of prime factors of 576. So if I multiplied all these together, I would get 576. Now, rather than rewriting these all as radicals, I'm just going to use the process that I know that if any two of these are the same, then that's going to be the whole number 2. So these two, another 2, and then these 2, and then these 2 3s, and then I don't have anything left, so I simply multiply these together. 2 times 2 is 4, times 2 is 8, times 3 is 24, so 24 is the square root of 576. So you can see how that prime factoring helps us then find these pairs of prime factors which we can then use to simplify our expression. Let's take a look at number 2 here. Again, we're going to take 32 and we're going to divide by the first prime factor of 2, and then we'll divide that by 2. We'll divide that by 2. We'll divide that by 2, and we'll divide that by 2 until I get all the way to the number 1. So these are the prime factors. I know that any 2 will equal the whole number of that radicand, so that would be 2. So I have 2 of these, and I have this 1 that's left over, so that has to stay underneath the radical, and then I can multiply these numbers now that are outside. So 4 square root of 2 would be the simplified version of square root of 32. Let's take a look at one more here where we don't have any number outside here. And number 3, we have 128, so again we're going to prime factor that using 2, and then we'll use 2 again, 2 again, 2, 2, 2, and 2. And again, we want to get all the way to the number 1. So we're going to use their pattern. We have 2 numbers that are the same, so that's going to be number 2. Then we have these 2 numbers that are the same. And then we have these 2 numbers that are the same, and then I have this 1 that doesn't have another one that's the same, so that stays as a radical. And then I can go ahead and multiply these together, so I get 8 square root of 2 would be the simplified version of the square root of 128. So let's look at number 5 here, where we have a number that's already outside the radicand. How does that affect us, if at all? Well, let's go ahead and prime factor this radicand just like we always do. So we look to see number 2 doesn't go into 343. 3, let's see, 610 does not go into this. 5 was not going to go into this. So let's try 7. I think 7 might go into it. So 7 into 34 would go 4 times. That would be 28 with 6 left over, 63. So this would be 9. And then 7 would go into that number, and then 7 would go into that, and so then we have our prime factors. Now, we already have a number outside, so we're going to have to keep that number, and then if we have 2 that are the same, it becomes a single number. And then I have this one prime factor by itself, so that stays underneath. And then just like we did with multiple prime factors that came out, we would multiply this together. So this would be 70. Square root of 7 would be the simplified version of this. All right, let's do a couple more just so we get the idea here. Over here at 4, number 6 here, 4 square root of 512. So again, 512 we're going to do upside down or prime factor. So this is divisible by 2. So this is going to be 256. And then that's divisible by 2. So 128. And that's divisible by 2. That's divisible by 2. And then 16 is divisible by 2. 8 is divisible by 2. 4 is divisible by 2, and 2 is divisible by 2. Okay, now again, we already have a 4 out here, so we have to keep that one. So these two are going to become a 2 on the outside. These two become 2 or simplify to 2. These two simplify to 2. These two simplify to 2, and then I have this 1 left over. So then I multiply all these together. So 2 times 2 is 4, times 2 is 8, times 2 is 16, times 4 is 64, with a square root of 2 left. So let's do number 8 here to wrap this up. So I have a 9, whoops, I don't want to start there. I want a prime factor 210. So dividing that by 2, that's 105. That's not divisible by 2, but is divisible by 3, so we'll divide this by 3, so that's 35. And that's not divisible by 2 or 3, but is divisible by 5. And then this is divisible by 7 and 1. So I have the number 9 on the outside. Now, I don't have 2 2s, I don't have 2 3s, I don't have 2 5s, and I don't have 2 7s. So nothing is going to simplify outside, so all of these numbers end up staying underneath the radical sign. But I don't want to leave it as 2 times 3 times 5 times 7, so what I'll need to do is to multiply those all back together. And so actually 9 square root of 210 is the simplified version of 9 square root of 210. So if we don't get pairs, just like we did on these other ones where we had, like usually we had one number that was left over and that stayed under the radicand or the radical sign, any number and all numbers that don't come out or don't have pairs of factors will have to stay underneath, so we'll multiply them together so we have a single number as a radicand and a single number on the outside. Okay, so that's simplifying radical. Those are a few examples, and I trust those were helpful for you.